All right, I think we'll get started. So, welcome everyone. Welcome back to day two. So this is day two of the workshop, building a foundation model for the brain, data sets, theory, and models. And today we're going to be focusing a bit more on the methods side of things. And yeah, I just like to say yesterday was a really big success. So hopefully we can capture some of that magic again for today. So just quick recap over what we went through yesterday. We started with some opening remarks from Cole Hurwitz and Mehdi Azabou, our other co-organizers. And then we went into some talks by Eva Dyer and Blake Richards on what foundation models really are and how the field of neuroscience can benefit from scale. Next, we had Andreas Tolius and Katrin Franke talk about how deep learning and other large modeling approaches could provide greater insight to neural function. And then on the data side of things, we had Gael Chapuis and Saskia de Vries introduce some open data sets, painstakingly processed and made available by the Allen Institute for Neurodynamics, as well as the International Brain Laboratory. Afterwards, we had Juan Gallego talk about shared neural dynamics across animals, where he speculated about the concept of a mother manifold, which was my favorite phrase from yesterday. And Quebec's very own Patrick Minot talk about how principles from neuroscience can be used to build safer foundation models. Finally, we had an awesome panel discussion between Andreas, Blake, Memming, and Saskia discussing their hopes and concerns about how foundation models could change neuroscience. This brings us to today, where the talks are more so centered around some of the methods that have been designed to help us get us on the path to building foundation models for neuroscience. Therefore, I quickly want to refer back to this figure, which shows that many different levels of the technical stack must go right to achieve this goal. A common concern described yesterday is the need for large quantities of high quality neural data, which is, just a classic thing in deep learning training as well. And this is starting to be addressed through initiatives discussed by Gael and Saskia, for example. On the pre-processing end of things, this would be critical for unifying all of these disparate data sets. One of the points made in one of the talks yesterday was the desire to pre-train these large foundation models on many different modalities of neural data. As we all know, different modalities are very different in terms of how they're structured, what they represent. So two modalities such as EEG and LFP, for example, it might be more intuitive in terms of how we could process both of these. They're both time series, but then how would we process two things such as neuronal spikes and fMRI, for example? Would we have to learn a universal encoder for both? Would we have to learn individual encoders? Is this even something that we'd want to do? And I would hope that some of these things are discussed in the later talks. In terms of the software, how do we train models? How do we host models? And what tools can we use to work with our data? I just want to give a quick shout out to some of the libraries designed by some of the people in this room, such as TorchBrain, which hosts some pre-trained versions of different models that were talked about yesterday, as well as BrainSets, which contains processed data sets that you could use to train your own models, as well as ways to play with and engineer your data, such as temporal data. Finally, I would be remiss to not mention the importance of benchmarking, which is crucial for any modeling effort. So how do we even determine how good our model is? For that, we have different things such as the Falcon benchmark, which is used to help gauge your few shot to zero shot performance on across multiple sessions in intracortical BCI decoders, as well as an incoming benchmark from IBL focused on decoding from mice. On this topic, someone asked an excellent question yesterday. Like, how do we gauge the goodness of a foundation model without looking at their performance on downstream tasks? Is this something that's even possible? So more things to think about, and I will pass it off to Nanda.
Something that was a common theme in a lot of the talks and the panel discussion that was mentioned yesterday is that this really should be a community effort that requires standardization and collaboration. And so someone after the talks and panel yesterday came up to me and asked me if we plan to host a community, and in fact we do. So we have a Discord for NeuroGalaxy, which is a project to discuss implementations and also just all the challenges associated with building these neuro foundation models. You can check out our Discord and GitHub, where you can find the TorchBrain and accompanying packages. And just this morning, Mehdi, one of our co-organizers, created an awesome repository, which is a collection of great implementations of Neuro Foundation models as well. So I just managed to add that link a few minutes ago. So yeah, maybe just give you guys a couple seconds if you want to grab a picture. 1, 2, 3, let's go. And so given that today's focus is going to be more on methods, I just wanted to highlight some of the efforts at this COSYNE, both at the main conference and this particular workshop, at tackling this problem of building Neuro Foundation models, sometimes with specific applications in mind. So first we have multitask masking. We have a talk about that today. We have POSSUM, which, well, shameless plug, it's Avery and my project. It's about extending POYO to the real-time BCI case. We have NEMO and NEDS, once again from Cole's group. LDNS, which is a generative model linking spiking activity and behavior. Again, a talk today. BrainLM for fMRI recordings. Learning state space models, metadynamical state space models to rapidly learn latent dynamics on new sessions. NDT3, one of the latest and greatest efforts on scaling up transformer models for BCI decoding, and Centaur, a foundation model for cognition, where you can predict and simulate human behavior in an experiment that you can express with natural language. So we're excited to hear about all of these latest updates on Neuro Foundation models. Something that I'd like to mention, since we're focusing once again on the methods, is that there are several modalities, and many of the modalities listed on the slide here are captured in the talks that we have today. So we have methods that work with spikes, LFPs, EEG, fMRI, and so on. And the challenge really is that these are very different kinds of data. Spikes are discrete events. LFPs, EEGs are regular time series signals. So the way we tokenize these, the way we input these to our models is really different. And these modalities also vary in how invasive or non-invasive they are, and the applications that they can enable span a wide set, which I've tried to summarize on this slide. So in the case of clinical and therapeutic BCIs, we, for example, have BCIs that attempt to rehabilitate speech in those who have lost the ability to do so. We have BCIs to control and interact with devices such as computers and VR headsets. We can apply Neuro Foundation models for disease diagnosis, analyzing progression and outcomes of treatments. And even for neuroscience itself, you could use these models, as we saw in some of the talks yesterday, for cell type identification. And maybe you could use digital twins in the experimental loop itself to generate hypotheses and maybe reduce the search space among the large set of hypotheses that exist. But we have some outstanding challenges, and I hope that some of these topics will be touched on today in all the talks. Data collection and pre-processing, the availability of data that spans a wide variety of naturalistic behaviors is a key concern, and ensuring that data sets are pre-processed in a standardized format is also important for comparisons across various methods that are coming out in this new field. Tokenization, as I mentioned earlier, is yet another challenge. Do we, for example, in the case of spikes, do we bin spikes, or do we use individual spike tokenization? Is there something beyond that can enable us to easily adapt to new subjects and new recordings? Evaluation, once again, a key concern. We have the Falcon and the incoming IBL benchmark, but we'd really like to see more of these benchmarks come out so that we can test these foundation models on a wide variety of downstream tasks, because that's probably the best way we have so far to understand how good they are, or if they are good at all in the first place. Interpretability is a big concern, and I feel like we might see some of that expounded upon today as well. And we touched upon it yesterday during the panels and talks as well. So hopefully in some of the talks that have been recorded, you can go and check those out to know more. And finally, I'd also like to touch upon efficiency during not just training and fine-tuning to new sessions, but also during inference to enable real-time BCI applications. And there are potentially many more challenges that I've not been able to include on this slide, but this is a nascent field, and I hope we can work out these challenges together. I'd like to shout out to today's speakers. We have a wonderful list of speakers and panelists today. Just a quick look at those who will be speaking. And I will end by just stopping at the schedule so you have an idea of the talks that we're going to have today. Last but not least, I'd be remiss to not thank my other co-organizers. I'd really like to thank Eva, Blake, and the Dream Team, Mehdi and Cole for organizing this workshop together with us. And lastly, but not least, you, the audience, for showing up here in large numbers and engaging in discussion. Thank you so much.